Now we're going to be looking into graphing basic trigonometric functions. Let's get right to it. Example 1, we're going to graph f of x equals sine of x. I'm going to go through some simple steps for you to be able to graph each of these trig functions every time accurately. So step 1 is going to be to draw the chart using the same x value. So key word here is we're going to use the same x values for every single trig function. Now remember, trig functions have angles as inputs. So our inputs are going to be angles, and furthermore, they're going to be in radians. And the reason they're going to be in radians is because a radian is a lot smaller numerically than a degree. For example, think how big 360 of a number is, 360 degrees. Now 2 pi radians is much smaller, that's around 6. So it's a lot easier to put on the grid if we use radians, which is what we're going to do. So again, step 1 is to draw the chart using the exact same x values. Okay, here's the x values that I personally have my students use when graphing trig functions. We're going to start at negative pi. Okay, why negative pi? Because that's around negative 3.14. It's to the left of 0, and it's not too big, it's not too small. And we're going to increment each x value by pi over 4. So the next x value is going to be negative 3 pi over 4. Let me show you a visual in the unit circle to help you understand why we're doing this. Okay, so we're starting at negative pi, right? And then we're basically moving like clockwork. We're moving in increments. That's negative 3 pi over 4, excuse me. We're moving in increments of 45 degrees to the right, or pi over 4 to the right. Then the next one is negative pi over 2, right? And then the next one is negative pi over 4, moving 45 degrees that way. Then we get to 0. Then we start to get to positive angles, pi over 4, pi over 2. Again, we're moving 45 degrees every time. And then we have 3 pi over 4. And then finally, you get back to the same angle, actually, right? Or the same cycle, and you get to pi, which is the same as negative pi. So that's all we're doing with our x values, and we're going to be using the same x values no matter what the trig function. That way we have consistency and we can compare which each graph looks like. All right. So those are all of our x values. I just explained why we use them, and then we're going to just plug them into the function. So for example, what is sine of negative pi? Well, that would be the y value, which would be 0 on the unit circle. So we're going to put y there. And then in order to graph these, we need a decimal. So I have a third column here which says y decimal. Well, the decimal is just 0. Okay, let's move to sine of negative 3 pi over 4. Sine of negative 3 pi over 4, the y value here is negative square root of 2 over 2. Again, if you don't know your unit circle, you need to go back and master that before you get to this lesson of graphing trig functions. Okay, so that as a decimal, well, negative square root of 2 is, square root of 2 is 1.4, so negative square root of 2 is negative 1.4. If you divide that by 2, you get negative 0.7. So again, in your third column for your decimal, you need to write what the decimal value is of that radical, or sometimes just a fraction. Okay, sine of negative pi over 2. Well, it's going to be negative 1 here. So I'm going to go ahead and write negative 1 for sine. And the decimal of that is just negative 1, obviously. Now, in case you guys are confused, I'm going to pull up this unit circle. So we just said negative pi over 2. You can see the y value is negative 1. How about sine of negative pi over 4? Well, again, negative pi over 4 is right here, which is the same angle, if we go back to our unit circle, as 7 pi over 4. What's the y value? Again, sine is y, and the y value is negative square root of 2 over 2. So when I go to my chart, at negative pi over 4, I'm going to put negative square root of 2 over 2, and it goes back to negative 0.7. Sine of 0 is 0, the decimal is 0. If we go to sine of pi over 4, we can see the y value is positive square root of 2 over 2. So therefore, sine is positive square root of 2 over 2. Excuse me. And the decimal for that is 0.7. Sine of pi over 2 is going to be positive 1 for the y value, and then we'll just finish the rest of this. Sine of 3 pi over 4 is square root of 2 over 2. Sine of pi back at the y value being 0, so sine is 0. So that will complete each of our rows. Notice that basically for your y values, you only have 3 different looking decimals. It looks like 0, it looks like 0.7, it looks like 1. Some are negative and some are positive. So look at this. Now we have all these x values. with y value decimals. We can go ahead and graph our function. Now I kind of did steps 2 and 3 here in one chart. Okay, so step 1 was to draw the chart. We want to call step 2 determining the y values, and I'll make that blue for you. So these y values we're going to put right here, and we're doing that using the unit circle. Okay, step 3 is to convert those to decimals. Okay, so if you look, once you get these y values from the unit circle, then you will convert those to decimals for step 3. And that's because without the decimal, it's very hard to put that on a graph. Okay, so just to reiterate, step 1, you're going to draw your chart with the same x values right here. Step 2 is going to determine their y values using unit circles. Step 3 is to convert them to decimals. Okay, moving on to step 4. You're going to plot each point on the graph. So we're going to take every single one of those points and put them on a graph. And I like to make them big so you can read them. So for example, the first point is negative pi comma 0. That's going to go right here on my graph. Now how do you construct your graph? Well, obviously for your x values, you're going to range from negative pi to pi. They're equally spaced because they increment in units of pi over 4, as I've shown with this visual right here. For the y values, if you look at the range, once you're done with your chart, none of these go above or below -1. However, when we're taking into account all trig functions, normally I go up to 2.5 at the top and down to -2.5 and increment that by 0.5. You'll see why when we go to do other trig functions. So let's move on to the next point. The next point was negative 3 pi over 4 comma negative 0.7. So I'm going to put a point at negative 3 pi over 4 and somewhere between negative 0.5 and -1. Again, this is just a sketch and it doesn't have to be perfect. The next value is negative pi over 2, -1. So I'm going to go over negative pi over 2, go down -1. Let's look at the rest of the points. Then negative pi over 4 and negative 0.7. Remember, you're looking at the y decimal. So you go back to negative 0.7 at negative pi over 4. Then we have 0, 0, pi over 4, comma 0.7, pi over 2, comma 1, 3 pi over 4, comma 0.7, and pi, comma 0. And that will finish out these last sets of points that we have on our chart. Now you can really see this graph starting to take shape. You can see why sine and cosine oscillate, right? That kind of looks like an S curve. So that leads us to step 5, which is to draw the vertical asymptotes for undefined y values. So this will not apply for sine and cosine, but for the other trig functions, there are vertical asymptotes. So this step 5 is important in case you do have vertical asymptotes, you want to sketch them. But for now, again, because it's sine and cosine, we do not have to do this step, so we can go on and move to the next step. Step 6 is to connect the dots with the curve of best fit. So obviously, like I said before, this is an obvious curve. Okay, now we do not want to draw arrows here because it doesn't just go down, right? It's going to oscillate. So all you need to do is just basically connect them with some kind of curve that makes sense to you. So again, that's step 6, connecting the dots with the curve of best fit. So now we can start to see what sine of x looks like. It looks like an oscillating curve, right? Step 7, draw a dotted line to the left and right of the graph to illustrate its repetition. So the reality is sine and cosine wave. So when I draw my dotted line, I'm going to indicate that it's going to wave up and down like this. And yes, you know, this is it, folks. This is our graph. This is our sketch. The only way we can really graph any function is to use points. And because we're using these same x values for every trig function, we can easily compare which each of them looks like and what their graph behavior looks like. That's it, folks. 7 simple steps to graphing trig functions. This is our final graph, and I will go ahead and write out what this is. This is sine of x, and it waves up and down. If you have any other questions about these 7 basic steps for graphing sine of x, let me know.